Welcome to the spoken tutorial on developing an equation-based model. In this tutorial, we are going to learn how to create a textual model in OMEdit and simulate it, how to declare variables and equations, how to use simulation setup toolbox. To record this tutorial, I am using OpenModelica 1.9.2 and Ubuntu Linux operating system version 14.04. But this process is identical in Windows, Mac OS X or Fossey OS on ARM. To understand this tutorial, you need to know equation-based modeling of physical systems. Let us simulate the motion of a ball of mass m under freefall due to gravity. Height of ball from the surface of Earth is represented by variable h. Velocity of ball is represented by variable v. Acceleration due to gravity is represented by g. It is assumed to be constant. Variables directed away from the surface of Earth are considered positive. The equations of motion for a freely falling body are as follow: dh by dt equals v, dv by dt equals g. The value of h at time t equals 0 is 30 meter. Value of v at time t equals 0 is 0. Now let me go to OMEdit. I have already launched it on my system. To open OMEdit on Ubuntu Linux operating system, click on dash home icon which appears at the top left in launcher. Type OMEdit in the search bar. Click on OMEdit icon. On clicking OMEdit icon, you see a window such as this. This window is known as Welcome Perspective. OMEdit by default opens in the Welcome Perspective. At the bottom right hand corner, you can observe buttons for Welcome, Modeling and Plotting Perspectives. Click on Modeling Perspective. Modeling Perspective has now opened. I will be referring to the area between Libraries browser on the left, Messages browser at the bottom, Toolbar at the top as the modeling area. The toolbar has various buttons related to file operations, graphical view and simulation. We will learn more about these buttons as we go along. Now we shall use freefall class file provided in the code files link on our spoken tutorial web page. Please download this file and save it on your system. To open this file, go to File menu in menu bar. Click on Open Model or Library File. Locate freefall file that you downloaded and saved on your system and open it. You may also use the tool named Open Model or Library File that my cursor is pointing to for opening a file. Note that freefall icon appears in the Libraries browser. Libraries browser shows all classes that are loaded in a session of OMEdit. Right click on freefall icon and select View Class. The class has now opened in diagram view. Do not worry if the class does not open in diagram view. I shall show you how to switch between different views. Go to the top of modeling area. Note that the second button stands for diagram view. Third button is text view. Click on it to switch to text view. The class has now opened in text view. Note that the first button stands for icon view. We will learn more about icon view and diagram view later on. You may also create a new class named freefall and type the required information. To create a new class, go to File menu, select New Modelica class. A dialog box pops up as shown. In the name field of this dialog box, type freefall. I am using a different name, freefall1, since freefall class is already open in OMEdit. Note that two classes, cannot have the same name. Click on Specialization drop-down menu, select Class. Click on OK. A new class has been created. You may also use the tool named New Modelica class to open a new class. Let me delete annotation section. Now you may type the required information here and save this class. To save this class, go to File menu in menu bar. Click on Save. Choose an appropriate location for this file and save it. Now let us understand the syntax of Modelica using freefall class. To switch to freefall class, go to top of modeling area. Click on Freefall tab. Programs in Modelica are arranged in the form of classes. The first line of a class defines its name. Name of this class is freefall. Every class must have an end statement to indicate where the class ends. This class has variable declarations and equations. Let me show you how to declare variables. Real represents data type. H represents height of ball from the surface of Earth. Start is an attribute of real variable. Every data type has certain attributes which specify useful information related to variables. Start attribute specifies the initial value of a variable. The initial value of H is 30 units. Unit attribute specifies the unit of a variable. The unit of H is meter. Every variable declaration must end with a semicolon. V represents velocity of ball. It is of real data type. The initial value of V is 0. Its unit is meter per second. G represents acceleration due to gravity. It is of real data type and its unit is meter per second square. Parameter is a quantity that remains constant in a simulation run. The value of G remains constant throughout the simulation run with a value of 9.81. The negative sign is due to sign convention used. The text in double quotes is a comment written with the declaration of G. Comments provide useful information about the program. They are also useful for documentation. Now let me go back to the slides. Parameter is a quantity that remains constant in a simulation run. Real, integer, Boolean and string data types are supported in Modelica. Start and unit attributes have already been defined. Min attribute specifies the minimum value of a variable. Similarly, max attribute specifies the maximum value of a variable. Let me go back to OMEdit. Equation signifies the beginning of equation section of a class. This is an alternative way of inserting comments. The two equations of motion for a freely falling body, as we have already discussed, have been included here. DER is Modelica function for time derivative. Hence, DER of H represents dH by dt and DER of V represents dV by dt. Every equation must end with a semicolon. Now let me show you how to simulate this class. Click on Simulate button in the toolbar. Close the pop-up window. This window is known as the plotting perspective. On successful simulation of a class, plotting perspective opens automatically. Variables browser displays information related to variables and parameters of a class. Note that there are columns named unit and description. Unit column specifies units of variables as defined using unit attribute. Description column displays comments written in double quotes with variable declarations. Let me show you how to generate a plot. Select H. This generates the plot of H with respect to time, with H on y-axis and time on the x-axis. By default, the simulation is run from 0 to 1 unit of time. The unit of time depends on the system of units used for other variables. Let me deselect H. It is always a good practice to delete the result once necessary plots have been generated. To delete this result, right-click on Freefall and select Delete Result. The result has now been deleted. Let me go back to modeling perspective. Click on Modeling button at bottom right. Class is used synonymously with model in Modelica. One may use model instead of class here to produce the same effect. Now let me show you how to change the time interval for simulation. Click on Simulation Setup button in the toolbar. Under General tab, locate Stop Time field. Change it to 5 units. Click on Simulate. Close the pop-up window which appears. Let me select H once again in the variables browser. This generates H versus time plot. Notice that the time interval has increased to 5 units, but the value of H has gone below 0, which is unacceptable. We will learn how to rectify this issue in the later tutorials. Let me delete this result by right-clicking on Freefall and selecting Delete Result. Go back to Modeling Perspective by clicking on Modeling button at bottom right. It is necessary to ensure that the number of equations in a class is equal to the number of variables. This class has 2 variables and 2 equations. Now let me delete the first equation and simulate this class to see what happens. I have deleted the first equation. Notice that a star appears beside the name of the class in Freefall tab. This indicates unsaved changes in the class. Hence, it is a good practice to save a class after a change has been made. To save this class, go to the File menu and click on Save. You may also use the Save button in Toolbar, which my cursor points to save a file. Now let me simulate this class by clicking on Simulate button. Note that an error message pops up in the Messages browser. It says there are too few equations and the model has 1 equation and 2 variables. Hence, this cannot be simulated. Now let me insert the equation back in its place and click on Save button in the toolbar. Click on Simulate button once again to simulate this class. Note that the class simulates successfully since the number of equations is equal to the number of variables. Close the pop-up window. Let me go back to the slides. DER is Modelica function for time derivative. There is no data flow direction for equations. For example, DER of H equals V may also be written as V equals DER of H. Initial equation section is used to enter initial conditions. We will learn more about initial equation later on. As an assignment, write a model to simulate the differential equation dx by dt equals minus a into x, where a equals 1, x belongs to R, and the value of x at time t equals 0 is 5. This brings us to the end of this tutorial. Watch the video available at the following link. It summarizes the Spoken Tutorial project. We conduct workshops using Spoken Tutorials. Give certificates. Please contact us. Spoken Tutorial project is funded by NMEICT, MHRD Government of India. We thank the development team of OpenModelica for their support. Thank you.